Hey guys, in this video the lovely Mr. B is going to be talking to you about trig identities, how we can use them for our A-level. Now there are lots of skills and techniques that you need to have sorted in this video. So to help you ensure that you've got them all ready for your exam, over on my website there are loads of questions just waiting for you.
Trigonometric identities are ways we can turn sin, cos and tan into each other. Now, the two most important ones are that if you have sine theta divided by cos theta, that's equal to tan theta. The other important one is that sine squared theta plus cos squared theta is equal to 1. So these are the two most important ones. Now, in this question, we'll be looking at the sine over cos equals tan, and then we move on to some of the harder questions. We'll look at the sine squared theta plus cos squared theta is equal to 1. But essentially what we're saying with that is, if you add together the square of a sine curve and the square of a cos curve, they kind of cancel out to give you kind of a straight line, to give you 1. Now, for this question, sine theta over cos theta is equal to tan. Now, in the question, we've got to think about which identity to use. And it says cos theta over sine theta. Now, that is the other way around. So the way that works is you've got to think about reciprocals, kind of flipping a fraction upside down. If the fraction is upside down, it's cos theta over sine theta. Then the fraction of tan theta is going to be upside down as well. And if it's not a fraction, you write it as 1 over. So what we've done here is we've taken the reciprocal of both sides. You take the reciprocal of a fraction, it flips upside down. If you take the reciprocal of just a normal number, then it becomes 1 over that number. So if sine theta over cos theta is tan theta, cos theta over sine theta is 1 over tan theta. Now, you might recognize 1 over tan theta. That's a definition of cot theta. Cot is the reciprocal of tan. It's 1 over tan. So what we actually have here is cot theta is equal to negative 2.222. Now, when we solve these, we really want to kind of keep it in terms of sine, cos, and tan because we know the graphs for those. So what we can do is we can say, well, if 1 over tan theta is equal to negative 2.222, then we can kind of rearrange this equation by taking the reciprocal of both sides again. And if we do that, 1 over tan theta becomes tan theta over 1. Then anything over 1, you divide by 1, it stays the same. And then we have 1 over 1 divided by negative 2.222. And that gives us a negative 0.45. Then let's do a few decimal places here so we don't have any rounding errors. Let's do 5 decimal places. So to use this trigonometric identity, you have to be familiar with sec, cosec, and cot, and the principle that they are reciprocals. They are 1 over sin, cos, and tan. If you're not familiar with that, then you need to go and have a look at the trigonometric equations videos to get a bit more confident. Now, once you know what's happened here, we've now got this into a form that we can solve. So if we have tan theta is equal to negative 0.45005, to continue solving the equation, we'll do the inverse of tan to both sides to get theta on its own, because that's what we're trying to find. And the inverse tan of negative 0.45005 is going to give us negative 24.2 degrees to 1 decimal place. So now we've solved the equation and we've got an answer. Now, the last thing to think here is that when we have our tan curve, and I've got a tan curve drawn out. Now, again, I've got a computerized version, but you would have to sketch this on your own. And the way to sketch it is you forget, just think, well, I can put tan 0 into a calculator and get 0. I can put tan 45 into a calculator or tan 1 into a calculator and get the other number. Tan 180 is 0. Tan 225 is 1, tan 135 is negative 1, and so you can kind of build up the coordinates that way. Now, the answer we have is the answer that's closest to 0, and so negative 24.2 degrees is roughly going to be around about here. You think it's negative 0.45. This is where it's going to cut through. So what we need to think is, well, we have alternate answers because these curves keep repeating. We need to check our range to see which ones of these alternate answers we want. Now, we want answers between 180 degrees and negative 180 degrees. So the answer we have, negative 24.2, that's within that range. That answer's okay. But we can see the next answer along would also be in that range. It's in between 135 and 180. So we need to find that one as well. Now, even with the computer-generated graph like I've got, it's really hard to read it off. So you need to use a symmetry of a tan curve. Now, all trigonometric curves repeat every 360 degrees, but tan is special in that it also repeats every 180 degrees. The distance between all the possible answers where the curve repeats is 180 degrees. That means if we take a negative 24.2 and we add 180 degrees to it, we'll get our second answer, which is 155.76. We frame that up to 0.8 degrees. Now, again, we're going to have an infinite number of answers here, so we could add another 180 on and get the third coordinate we've got on this graph, which is in between 315 and 360. And that's 335.8. However, we've got our range. We want our answer between negative 180 and positive 180. So actually, that answer's too big. We don't want it. Similarly, we could be taking away 180. And so negative 24.2 take away 180 would give us negative 204.2. And again, while that's a possible alternate answer, it's not within the range we want, so we're not going to write it down. So we have two things to look at. The first thing is, when you have your trigonometric equation, we have to think about trigonometric identities to change it into a form that we're more comfortable with, that we can solve. That's our first step. That's where we turn cos theta over sine theta into 1 over tan theta. Once we've done that, we then have to use our skills solving trigonometric equations like we've done in previous videos with all the same rules. Now, as well as tan theta being equal to sine theta over cos theta and sine squared theta plus cos squared theta being equal to 1, there are other trigonometric identities. So the next step we'll look at are the double angle formulas. So for these, we're going to have sine of 2 theta is equal to 2 sine theta cos theta, which is also equal to 2 tan theta over 1 plus tan squared theta. And that's kind of derived by rearrangement from the two we just talked about. Again, the tan theta being sine over cos, and the sine squared plus cos squared equals 1. So these are just rearrangements of those. So we've got one for sine of 2 theta. We've also got one of tan 2 theta. Tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Now, of course, we have these for sine and tan. We've got them for cos as well. There's a few more rearrangements for cos. So cos 2 theta can be equal to cos squared theta take away sine squared theta. It can be equal to 2 cos squared theta minus 1. It can be equal to 1 minus 2 sine squared theta, and we'll try and squeeze the last one in, equal to 1 take away tan squared theta divided by 1 plus tan squared theta. Notice how tan's always appearing as a fraction. Again, that's because tan theta is equal to sine theta over cos theta as a fraction. So tan's always shown up as a fraction. Whereas sine and cos relate to each other in terms of being squared, so you have the square number in for sine and cos usually. Now, out of all of these, we have to select the one that's going to be relevant for us. So looking at the question, we have 2 cos squared theta minus 1. So we have to look through this list and see which one that is. And I can see it here, 2 cos squared theta minus 1. So what's that equal to? Well, it's equal to cos of 2 theta. And hopefully you recognise that 2 cos squared theta minus 1 is a little bit complicated, but cos 2 theta is going to be much more reasonable. So now we can rewrite our equation. Cos of 2 theta is equal to 0.92. All we need to do now is do our steps to solve the equation. So we can do inverse cos to both sides to get rid of cos. On the left-hand side, that will leave 2 theta. And this should be looking like some questions you'll be familiar with from the trigonometric equations videos. If you're not familiar with the trigonometric equations videos, go and watch them now because the rest of this video is going to be using all those skills. So cos to the minus 1, 0.92. That gives us 23 point, let's just do one decimal place, 23.1. Now that's for 2 theta. Let's check our range. Our range is actually in between negative 180 and positive 180, but that range is for theta. We've got 2 theta. So the range for 2 theta will be double that. It'll be in between 360 and negative 360. If you look at what I've just written down here, just notice I just multiplied every single part of the inequality by 2, with the middle part being especially important because it's showing that this is a range for 2 theta. So we've looked at the range. Now let's look at the possible alternate answers. Now, 0.92 is going to be cutting through the top of the cos curve up here. And we've already got our first answer, which is the 23. You can see that's in between 0 and 45. So now we need to use the symmetry of the cos curve to get our other answer. Because again, even on a graph like this, I can't really read off this second answer. It's actually plotted, but it's not big enough for me to see where exactly in between 315 and 360 we are. So the symmetry for a cos curve is right through the middle, through 180. So if we are 23 in from the left-hand side, we'll also be 23 in from the right-hand side. And so the right-hand side starts at 360, take away the 23.1, and this will give us an alternate answer. It's going to give us 336.9 degrees. Now, looking at our range, we're in between negative 360 and positive 360. And so these two answers are within that correct range. But we have to think these graphs do continue on. It's going to continue on past 360 into values outside our range in the positive way, but it's also going to be a negative version of this curve as well. And we can go down as far as negative 360. Now, again, think about the symmetry of these. They repeat every 360 degrees. So we've got the two answers in between 0 and 360. We can get the rest by adding or taking away 360. So 23.1 take away 360 will give us negative 336.9. That number should seem familiar. It's a negative version of the second answer we had before. Then 336.9, the positive one, take away 360, will give us negative 23.1 degrees. And this is the pattern you find with cos curves, that the positive answers have negative versions. And all four of these are within our acceptable range. If we try to take away 360 again, or adding on 360 again, then we're going to go outside that range. Now, these are answers for 2 theta. We want answers for 1 theta, so we have to divide both sides by 2. 2 theta divided by 2 is 1 theta, and then we divide the right-hand side by 2. We do have to divide every single one of the alternate answers. So 23.1 divided by 2 is going to give us 11.55, and there's going to be a negative version of that as well. Then 336.9, divide that by 2, we're going to get 168.45, and a negative version as well. Now, thinking about my rounding, I haven't really planned ahead in my rounding, and I rounded to 1 decimal place way too early because my final answers, I've kind of left them to 2 decimal places here, but the previous ones were 1 decimal place. So thinking about this, what I need to do is my future questions, I need to write my initial angles perhaps to 2 or 3 decimal places. So then my final one, we don't have any rounding errors. And I've left that mistake in because I just want you to see that all of your kind of algebra and the steps you take and the identities can all be correct and get loads of marks, but your final answers can lose a bit of accuracy if you are careless with your rounding like I've just been. So again, always work to, a couple of decimal places extra than what you want at the end. So if I wanted 1 decimal place at the end, then the 2 theta, that should have been, to 2 or 3 decimal places. Now, our next question also has some very complicated trigonometry. We've got 1 minus tan squared theta and 1 plus tan squared theta. So I'm going to look at the double angle formula. I'm going to try and find it. And I think it's the one right at the end. And that's the same as cos of 2 theta. So again, hopefully you recognise that writing cos 2 theta is a lot easier than writing 1 minus tan squared theta over 1 plus tan squared theta, because then this one's will be relatively simple to solve. So our first step is to do inverse cos to both sides. That'll give us 2 theta is equal to the inverse cos of 0.41. And I'm going to pay attention to my rounding this time. I'm going to do it to 3 decimal places. It's 65.795 degrees. And that's for 2 theta. So now let's have a look at our range and let's look at the alternate answers. So our range is in between 0 and 360 for theta, but so far we've got 2 theta. So we multiply by 2. 2 theta is going between 0 and 720 degrees. So that's our range dealt with. Now let's look at the alternate answers. Now for cos 0.41, I'm going to be going through around about here. We've got our first answer. Now we can see it's in between 45 and 90, and we've got 65.795. So that makes sense for us. So our first answer is 65.795 in from the left. So the next answer is in between 270 and 315, keeping in mind that the symmetry of a cos curve is through the middle, through 180, then it will be going in 65.795 from the right. The right-hand side is at 360. So if we take that away, we're going to get a second answer, which is 294.205 to 3 decimal places. Now, again, thinking about the symmetry of these, they repeat every 360 degrees. Now, we don't want any negative answers, but we can afford to add 360 on because we can go as far up as 720, which is 2 lots of 360. So I still got on my calculator the 294.205. Let's add 360 to that, and we'll get another alternate answer, 654.205. Then look at the 65.795. Let's add 360 to that. We do this to all the alternate answers, and we get 425.795 degrees. And you'll find that if you continue to add 360, you'll go outside the 720 maximum. So these are the 4 answers that we want. Now, for our last step, we just want to divide both sides by 2. And I'm going to write the final answers to 1 decimal place. So theta is going to equal, so 65.795 divided by 2 is going to give us 32.9 degrees to 1 decimal place. And there shouldn't be any rounding errors here like the last question, because I've gone from 3 decimal places to 2 decimal places. So there's plenty of room for any errors to kind of cancel themselves out there. Our next answer is 294.205. Let's divide that by 2. And we get 147.1 degrees. Then 425.795, divide that by 2. And we get 212.9 degrees. And then 654.205, divide that by 2, and we get 327.1 degrees. So we've got 4 answers. At the end, double check, do these fall in our range in between 0 and 360 for 1 theta? And they all do. So we've got 4 answers, 4 correct answers. For the next question, we've got another set of trigonometric identities. Now for this one, sine of the angle A plus B is equal to sine of the angle A multiplied by cos of the angle B plus cos of the angle A multiplied by sine of the angle B. And this works when you're adding. It also works when you take away A and B. So we can write plus or minus because it works if you're adding or taking away. You just use add for add and take away for take away. There's also a version of this for cos. So cos A plus B is equal to cos A multiplied by cos B minus sine A multiplied by sine B. Now, you'll notice for this one that if you add the angle A and B within cos, then in the more complicated version, you're actually taking them away. So it's the opposite symbol. Now, if it was cos A minus B, then you'd be adding in the more complicated version. Just have a quick look at the plus or minus symbols. You'll see that in the longer version, it's upside down. And that just means that it's the opposite sign. So for the sine version, A plus B, and then sine cos, cos sine, both of those have got the same order of plus on top, minus on the bottom. So if you use plus, you use plus. If you use minus, you use minus. For cos, if you use plus, it's going to be a minus. And if you use minus, it's going to be a plus. It's the opposite sign. So be careful with that. There's also one of these for tan. Tan plus or minus B is equal to tan A plus or minus tan B, all divided by, then we have 1 minus plus. That means it's going to be the opposite sign. So for the numerator, it's the same sign. For the denominator, it's the opposite sign. And then it's tan A multiplied by tan B again. So these look like really, really complicated bits of trigonometry. Again, they're kind of derived from the basic facts by rearranging that tan theta is equal to sine theta over cos theta, and sine squared theta plus cos squared theta is equal to 1. So these are just rearrangements. But you can see the complicated versions can be made quite simple. So now let's have a look at our question. Now the question, we've got cos 3 theta cos 2 theta plus sine 3 theta sine 2 theta. So we have to think about which one this is. Now we've got a double cos and then a double sine. That's what we see when we've got a cos A plus B. So this is the one we've got, so this is the one we're going to use. We have to think what A and B are. So A looks like it's going to be 3 theta, and B is equal to 2 theta. So now we do our substitution. So we have cos of A, which was 3 theta, and cos of B, which is 2 theta, and it's a plus. Then we've got sine 3 theta, cos of 2 theta. So then when we substitute it in to our cos, again, we know that A is 3 theta. We know that B is 2 theta. Now, because it's a plus in the middle, remember, it's the opposite sign with cos, so it's going to be a takeaway. And cos 3 theta take away 2 theta is going to be cos of 1 theta. That leaves us with cos of theta is equal to negative 0.63. So something that's written quite complicated actually becomes something that's much more simple. All we need to do now is inverse cos to both sides, and that will give us theta is equal to the inverse cos of negative 0.63, which gives 129.1 to 1 decimal place. I'm not bothering into 3 decimal places here because we're already at theta, so we don't need to kind of make any adjustments to that. Now we need to think about alternate answers. Now going through negative 0.63, which is roughly here, and our first answer is coming in just before 135, which 129.1 does. That makes sense. We want the second possible answer at the same height between 0 and 360. So if we think that our line of symmetry is going to be through 180 with a cos curve between 0 and 360, if we go in 129 from the left, then we're also going in 129 from the right. That means 360 take away 129.1 will give us our second answer, which is 230.9 degrees. But you'll notice that's outside of our range, because checking the range, we want to be between negative 180 and positive 180, and that's outside that range. However, again, thinking about the symmetry of these curves, they always repeat every 360 degrees. So we can take 360 away from these answers to get the alternate answers. So we take 360 away from 230.9, we are going to get negative 129.1. Now take positive 129.1 and take away 360. That's going to give us a negative 230.9. Now the 230 answers are too big, so we don't want those. Again, because we're outside the range, we're just left with a positive and negative 129.1. And as a little bonus here, since we've been looking at the positive and negative symbol for positions where you can use both, you can actually write your answer as theta is equal to positive or negative 129.1 degrees. So you combine the two answers together by using that notation. Now the last of these questions is also another one of these formulas where we have something that's really, really complicated, but then we can see that, well, it's in our list of formulas here, and it's going to become something quite simple. So we're going to think about what the angles A and B are. Now, in the position of A, we can see we've got 1 theta. And in the position of B, we can see that we've got 2 theta. So then we write down tan of A plus B. That's going to give us the tan of theta plus 2 theta. And you can see it's a plus because we've got a plus on the numerator of our original version. So it's going to be a plus in our formula. That's the same as tan of 3 theta, which is the same as negative 0.28. So now just solve the equation, do the inverse tan to both sides, and that will give us that 3 theta is equal to the inverse tan with negative 0.28. That's going to give us negative 15.642 to 3 decimal places. Because you can see we're at 3 theta here. We've got some more maths to do, so we don't want to lose any accuracy by rounding too much at this point. Now this is 3 theta. Our range is actually 0 to 360. So for 3 theta, multiply through by 3. The range for 3 theta will be between 0 and 360 times 3, which is 1080. Now, we're looking for our alternate answers. We can think, well, it's a tan curve, and we know the symmetry in a tan curve is that it repeats every 180 degrees. So we can type the negative 15.642 into a calculator, and we can just keep adding 180 until we get past 1,000, which is our upper limit. So add on 180 once, and we get 164.358 degrees. Add on another 180, and we get 344.358. We can add on another 180, another 180, and we can see we're still inside the range. So add on another 180, and let's try one more. Now the next one gets us to 1,064, and our limit's 1,080. So we're actually slightly inside the limit even with this one. Then we add on another 180, we get 1,244, which is outside of that range. So we've got one that's too small, it's below 0, and we've got one that's too big, it's above 1,080. So altogether, we've got 6 answers to look at. Now we have 3 theta, and what we want to find is 1 theta. So if we divide both sides by 3. Now we've got some space on the left to write this out, so let's write out 1 theta over here. What we need to do is literally write out all 6 of these numbers and divide them by 3. So 164.385 divided by 3 will give us 54.8 degrees to 1 decimal place. To the next one, 344.358 divided by 3, That's going to give us 114.8 degrees. Now, a little shortcut here is it's going to take quite a lot of time to type all these into the calculator and divide them by 3. If you think about it, if tan 3 theta repeated every 180, and we had done 180 each time, if we divide by 3, it's going to repeat every 60. 180 divided by 3 is 60. And 54.8 plus 60 does give us 114.8. So a cheeky little shortcut here is we can just keep our 960 degrees and it'll give us the rest of the answers. And then we don't have to do the divide. So if you can spot patterns like this, feel free to use them to speed things up. But if you're not confident, just do it a long way and literally type in all 6 numbers and divide them by 3. But now we've got our 6 answers within the range 0 to 360, and we've finished the question. For the next question, we have something that looks like a quadratic. And what we want to do is rearrange this to be more like a quadratic you can solve. So we want our squared term. So we've got 15 sine theta. Then we want our kind of sine term. So we have 1 sine theta. Then we want our number term. It's on the wrong side. So we can take 6 away from both sides and have a negative 6. And now we made it equal to 0. Now I want to treat this as something like 15x squared plus x plus, or rather minus, actually for this one, minus 6. Just pretend it's actually a normal quadratic with an x rather than a sign in there. And what we're going to do is we want to kind of solve this as you normally would. So you might want to do completing the square. You might want to try and factorize it. So for this one, we'll try and factorize. Now, I'm going to do this using inspection. So I'll have a little bit of a 6. So that's probably going to be 2 times 3. Then we want to get a positive 1 in the middle. But then the x terms need to make 15. So we're going to have, it's probably going to be 5 times 3. So let's maybe try it this way around. Now, is this going to multiply out to give us what we want? So we're going to have 3x times 3 will be 9x. 2 times 5x will be 10x. So we want the 10x to be positive, so it'll be a positive 2. So kind of just using a bit of experience and guessing and knowing what you normally kind of do with these things, this is what I've come up with. Now, I'm not going to go through factorizing these in too much detail because we've got other videos for that. But if you don't know what to do here, you can even use the quadratic formula, for example. But the point is that you have a trigonometric equation. It looks like a quadratic. So you pretend it's quadratic and you solve it using any method you like, so inspection, like I've just done, completing the square, or quadratic formula. Now, once you've done that, we then need to solve this. To make it equal 0, to make either one of the brackets be 0. For the first bracket to be 0, the 3x would have to equal 2, or negative 2 rather, because then negative 2 plus 2 would make 0. For the second bracket, 5x would have to equal 3, because then again, 3 take away 3 would give us 0. That means the first bracket, x is equal to negative 2/3. And for the second bracket, x will be equal to 3/5. Now at this point, this is where we bring the trigonometry back. Now we swap sine for x. So now what we do is we swap x for sine. So sine theta is equal to negative 2/3, and sine theta is equal to a positive 3/5. And so what when we do our next step, trying to solve this, we do the inverse of sine to both sides. We do that for both possibilities. And it's going to give us a list of values for theta. So theta is going to equal, we're going to have the inverse sine of negative 2/3. So you can open a bracket and do negative 2 divided by 3 for that, for example. And that's going to give us a negative 41.8 degrees to 1 decimal place. For the second one, we're going to have the inverse sine of 3/5. So we can use 3 divided by 5 for that. You can use 0.6, it's the same thing. So we're going to get 36.86. We're going to round it up, so 0.9. Now, after this, all the usual rules apply. So if the sine theta is equal to negative 2/3, negative 2/3 is 0.6 recurring. It's going to be roughly down here. And we have our first answer, which is the negative 41.8. Actually, you bring the curve backwards. This I'm highlighting now in pink is going to be where our first answer is. So that looks like it's going to be roughly at negative 41. Now we can see there's 2 other possible answers, so we need to identify those. Now sine curves repeat every 360 degrees. So we take our 40 out. If we add 360, we're going to get the second value, which is going to be 318.2 degrees. So you can see that's the one that's kind of just below the 315. So what about the other one? Well, the symmetry in a sine curve is going to go through 270 in between 180 and 360. Now, we've got 318.2. 360, take away that, is going to give us 41.8. So we know that we are 41.8 away from 360 from the right-hand side. From the left-hand side, it's going to be 41.8 away from there. And the right-hand side bit of symmetry starts at 180. So 180 plus 41.8 is going to give us the other answer, which is 221.8 degrees. So we've got the three answers we can see on the graph there. Now, the next thing to do is do the same process for the 36.9. Now, that was from 3/5. 3/5 is going to be 0.6. That's going to be up here. Now, you can see there are two answers in between 0 and 360. The first one is just before 45 degrees. So that's the one we've got, 36.9. Now, again, look at the symmetry of this as symmetry through 90 degrees in between 0 and 180. So if we are 36 in from the left-hand side, we're going to be 36 in from the right-hand side. The right-hand side's at 180. So let's take away the 36.9, and that's going to give us the other answer, which is 143.1 degrees. Now, we want our answers in a certain range. We want them in between negative 180 and a positive 180. So looking at the answers so far, we've got some that are larger than 180, so we need to get rid of those. We are also allowed answers at a negative, and we don't have the negative kind of axes on here. I know I've tried to draw in the negative 41.8, but anything lower than that's going to be a little bit complicated to draw. Now, again, taking a sine curve repeated at 360 degrees, we can take 360 from our existing answers. So if we take 143.1, we can take 360 from that and get another answer. And that's going to give us 216.9 degrees. You can also take the 36.9 and take 360 from that, and that will get us a negative 323.1 degrees. So we can see these numbers, these are too large. They're going to be outside the 180 range that we're allowed. So we don't want those. So we can just cross them out. It's always worth checking. Now, on the other side, we have the negative 41.8 degrees. Now, you get that if you do 318 take away 2. If you take 360 from that, that'll get you the negative 41.8. Now, you take the 221.8 and take 360 from that, that gives us negative 138.2 degrees. Now that is inside our range. So when checking a range, always thinking about, can I add or take away 360 from all of my answers to get other alternate answers? And we have actually found one. The last thing you might want to do is just write out your answers in a bit more of a neat format, given that we've crossed so many out. So theta is equal to negative 138.2 degrees, negative 41.8 degrees, positive 36.9 degrees, and positive 143.1 degrees. So let's have a look at some more examples. So our next example is 12 cos squared theta plus 4 cos theta equals 1. The first thing we need to do is try and write it as a quadratic. So we could think, well, we're going to have 12x squared plus 4x minus 1 is equal to 0. So I've swapped the cos for x because that's something you'd be familiar with when you're solving a quadratic. You can leave cos in if you like. And I've put everything on the left-hand side. So I took 1 away from both sides to make it equal to 0. So now we have to factorize this. So again, use any method you like. You can use completing the square. You can use a quadratic formula. You can use inspection. Now we know it's going to be an x times x is x squared. And a 1 times 1 is 1. So the thing is going to be the coefficients on the x to make the 12. Now, given that we're looking at a 4x in the middle, it's probably going to be 6 times 2 to make the 12. Because of the 6 and 2 will also make the 4 if we actually take away the 2x. But we take away 2x, the opposite one's going to be negative. Because then we have the negative 1 times 2x. So I've done this using inspection. I'm quite good at it, obviously I'm a teacher. If you're not confident with factorizing that, then go and have a look at the factorization videos because it's not what this topic's focusing on. So we've factorized using any method you like. Now we need to think about how you make this equal 0. So 6x would have to be equal to 1 because then 1 take away 1 is 0. You multiply by 0, you get 0. Or the 2x would have to be equal to negative 1 to get 0. That means that x is going to be equal to a sixth, or x is going to be equal to a negative half if you solve those equations. So now we've solved it, we're going to put the cos back in. That means we're going to have cos theta is equal to 1/6 and cos theta is equal to a negative half. Now, 1/6 is equal to 0.16 recurring. So we're going to be looking roughly around about here in our graph, about 0.16 recurring. I'm going to get a couple of answers. I'm going to look at negative a half, which is going to be around about here, and that's going to give us two answers as well. I'm going to investigate each set of these separately. So if we do cos to -1 to both sides or both versions, I'll get our next step. So cos to -1 of 1/6 should give you that theta is equal to 80.4 degrees. So we can see that's going to be the answer here at 80.4. It's just before the 90. Then we need to think about alternate answers. So if we're going in 80 degrees from the left, then we're also going to be going in 80 degrees from the right, because a line of symmetry in a caused curve is right through the middle in between 0 and 360. So 360 take away 80.4 will give us 279.59, so it'll be 0.6 to one decimal place. When you just look at this, you see it's after the 270, so that roughly is going to be right. Now let's look at the other alternatives of theta. So inverse cos of a negative half is going to give us exactly 120. And again, that's in between 90 and 150, 135, that makes sense. So if we're 120 from the left-hand side, for the other answer, will be 120 from the right-hand side, and 360, take away 120, is 240 degrees. Now we've got our two alternatives, we have to look at the range to see if we need anything else. Now the range is in between 0 and 360. So we don't need to do things like add 360 for things past 360 or take away 360 for negative answers. We've got the four answers we need here. So these are going to be the final answer. They're all within our range, so they're all acceptable answers. One thing I want to do is at the end just consolidate all your answers and write them out neatly. So theta is equal to 80.4, 120, 240, and 279.6 degrees. Next, let's look at a tan question. So we have 15 tan squared theta plus 6 equals 19 tan theta. So we're going to write it as a quadratic. So we're going to have 15x squared. So again, just changing tan for x, make it a bit more familiar. We're going to take the 19 tan away from both sides to make it equal 0. So we have to factorize. So with a 15, typically you're going to see 5 and 3. You could see 15 and 1 as well, but I think that's unlikely. We could try 2 and 3 to make 6. It will have to be negative to make a negative middle term and a positive end term. If we multiply this out, we'd have 5x times negative 3, which would be negative 15x, and negative 2 times 3, which would be negative 6. That'll make negative 21x. Now, we actually want a negative 19x. So that's not going to work. So let's have another go. Well, what if we swap around the 2 and the 3? Let's see what that does. That'll be 5x times 2, which will be negative 10x, and negative 3 times 3, which would be negative 9. That is going to make a negative 19x. So it looks like we've found our factorization. Now, again, I'm really confident with this, so I can use inspection and do a bit of trial and error with this. If you're not that confident, again, completing the square might work, or even the quadratic formula if you can't see any good way to factorize it. But the point is that you're going to factorize this using any method that you know. Once you've factorized, we need to solve it for 0. So 5x would have to equal 3 to make the first bracket be 0, and 3x would have to equal 2 to make the second bracket to 0. That means that x will be equal to 3/5 or 2/3. So now we're going to put tan back in. That means that tan theta is equal to 3/5, and tan theta is also equal to 2/3. So looking at our graph, 3/5 is going to be the same as 0.6. So we can see that we've got two answers at that height. And 2/3 will be 0.6 recurring. It's going to be a little bit higher, but not too far away actually. And we can see we're going to have two answers there. So now let's do our next step. Let's do the inverse of tan to both sides or both versions. That means that theta is going to equal the inverse tan over 3/5, which is going to give us 30.96 degrees. That's going to round up to 31, isn't it? And then with that one, we know that tan kind of repeats every 180 degrees. That's a symmetry in the tan curves. So if we add 180 to that, we're going to get the second answer that's in between 180 and 225. So 31 plus 180 is going to give us 211 degrees. Now let's have a look at the second alternative. So inverse tan of 2/3 should give you 33.7, actually. And again, we can see that's a number that's just above the 31. See how close they are together. So for the next one, add 180 to it, and that's going to give us 213.7 degrees. And again, that's going to be the second answer. So we can see how close these are together on the graph sketch, and now we can see it in the numbers. Now let's check the range. So our range is in between 0 and 360. So we don't have any negative numbers to look at. So these four are within that range, so they're going to be our final answers. And again, at the end, perhaps just write them all out in ascending order. 31.0, 33.7, 211.0, and 213.7. So what I hope you're seeing here is that if you have a quadratic as part of your trigonometric equation, then just solve the quadratic first. You get two values for theta, and then you just continue as you normally would. Again, because it's a quadratic, you're going to have two separate answers to do all the usual steps. Where these get more complicated is we've got a mix of sine and cos. And what that means is when you try and write this out, you might end up with something like, well, let's say that sine is x, so we'd have 12x squared. And then we say, well, cos can't be x because sine's x, so what if cos is y? So you're going to end up with something like this, and it's not a quadratic you can solve because it's got two different variables. So it's a bit of a dead end. So what do we do in this situation? Well, we're going to go back to our trigonometric identities, and it's the one we didn't use right at the start, which is that sine squared theta plus cos squared theta is equal to 1. And this identity can be rearranged. And if you rearrange it, what you're going to get is sine squared theta is equal to 1 minus cos squared theta, and cos squared theta is equal to 1 minus sine squared theta. And now what this means is we can actually change sine into cos and cos into sine. Now the way it's written, we've got sine squared theta equals, and we actually have sine squared theta in our equation. So if we have 12 sine squared theta is equal to 8 cos theta plus 13, the bit we're replacing here is the sine squared theta, and it's going to change into 1 minus cos squared theta. That's going to leave us with 12 lots of 1 minus cos squared theta is equal to the rest. So if we expand the brackets, we're going to get 12 take away 12 cos squared theta is equal to the rest. And I want to put all this onto one side. Now, given that the squared term is a negative, we probably want that to be a positive. Let's move everything onto the right-hand side. So we're going to add 12 cos squared theta to both sides, leaving 12 cos squared theta on the right-hand side. The rest of the right-hand side is going to stay as it is. And then we want one of the sides to be equal to 0, so we're going to take 12 away from both sides. So this is a rearrangement, and then 13 take away 12 is actually going to give us 1, so we can correct them. Altogether, we've got 12 cos squared theta plus 8 cos theta plus 1 is equal to 0, just by expanding the brackets and collecting all the terms on one side. Now again, this is going to give us a quadratic, so we could say 12x squared plus 8x plus 1 is equal to 0. So what we want to do now is we want to factorize this. So again, I'm going to do this by inspection. You might want to use maybe the quadratic formula. To get the plus 1 at the end, it'll be 1 times 1. To get x squared, it'll be x times x. We need 12x squared. That's probably going to be 6x times 2x, because then the 6 and the 2 gives us the 8 if we add them together. So that's probably going to be our factorization. That means that 6x will have to equal -1, and 2x will have to equal -1 to make one of the brackets equal to 0, meaning that x is equal to a -6th, and x is also equal to a -1/2. And now to solve the quadratic, we can put cos back in. So cos theta is going to equal -6th, and cos theta is going to equal a -1/2. So now what we want to do is we want to solve this to get theta. So to get our values of theta, first we're going to do inverse cos of -1/6, and that's going to give us 99.6 degrees to 1 decimal place. Now, 1/6 is 1/6 recurring, so that's going to be roughly around about here on the graph. So yeah, first answer just after 90, and it's 99.6, that makes sense. So as usual, look at the symmetry. It's cos, we're going through 180. If we're 99.6 in from the left-hand side, the other answer will be 99.6 from the right-hand side. 360, take away 99.6 is going to give us 260.4 degrees. Now, if we look at our range, the range of this is going to be between negative 180 and a positive 180. And 260.4 is too big. But if we take 360 away from it, it's going to give us a negative 99.6. And this should remind us that with a cos curve, you're going to get negative versions of these answers. All we have to do now is just cross out the 261s because we're outside our range. That leaves us two answers, 99.6 and negative 99.6. Moving on to the second version, we want the inverse cos of negative a half. That's going to give us 120 degrees. Again, if we look on the graph, we've got roughly the location of a negative half. We've got 120 degrees. So if we're 120 in from the left-hand side, we'll be 120 in from the right-hand side for our final answer. 360, take away 120 is 240. Now, again, that's outside our range, but if we take 360 away from it, get some negative answers. So we get negative 120. We must also have negative 240, but of course they are outside our range. So now we can write down our final answers. Theta is equal to negative 120, negative 99.6 is equal to positive 99.6 and positive 120 degrees. So they are our four answers. A little extra detail as well. If we're writing things to one decimal place, we need to write everything to one decimal place. Actually, let's write negative 120.0, just showing that it is actually rounded to one decimal place. And the same thing with a positive version as well. Our next question also has a mix of cos and sine. So we have to use trigonometric identities to get them into just one of those. Now, cos squared theta is equal to 1 minus sine squared theta. So we can change cos squared into sine using that method. That means we're going to have 15 lots of 1 minus sine squared theta be equal to 2 sine theta plus 14. So we want to rearrange this and get everything onto one side. So multiply out the brackets. We're going to have 15 minus 15 sine squared theta is equal to 2 sine theta plus 14. So we want to kind of keep the right-hand side here. So we want to add 15 sine squared theta to both sides. That will get it onto the right-hand side, the rest of which is going to stay the same. If you're a bit confused by this, do it in more steps. But again, try and get everything to one side, with the squared term being positive. So then we have the plus 14, but then we want the other side to be equal to 0. And so we want to take the 15 away from both sides. That means that it's actually going to be a negative 1 on the end of this. And again, I know I'm skipping multiple steps here. So if you're not confident with your rearranging, do it in many, many more steps so you're confident with it. So now we're going to factorize this. Now, we could do like the other questions, and we could just change it into x, but we can keep it as sine as well. So sine theta times sine theta will be sine squared theta. We want to get a negative 1, so that'll be 1 times 1 to get that. So now we're going to think about the 15. Well, 15 is going to be 5 times 3 for us to get that positive 2. The 5 is going to have to be positive, so the opposite side will be positive to make the 5 sine theta positive. And then the other side will be negative. And again, skipped a lot of work there with factorizing the quadratic. So again, you can also do that with many, many more steps, perhaps use the quadratic formula if you're not confident. Now, it has to equal 0, so let's make each bracket equal 0. So 5 sine theta would have to be equal to 1, and 3 sine theta would have to be equal to negative 1 to make each bracket equal 0. That means that sine theta is going to be equal to a fifth, and sine theta is going to be equal to a negative third. So just an example here of not replacing sine with x and just working through with sine theta as your variable. Something you can do if you're confident. So now let's find out what theta is going to be. So to get theta from sine theta, we need to do inverse sine. First, we're going to do inverse sine of 1/5. That's going to give us 11.5 degrees. So we have a look at where a fifth is on our graph. We can see where our first answer is right at the start. Now, if we're 15 degrees in from the left-hand side, we're going to be 15 degrees in from the right-hand side because of the sine curve. Line of symmetry is through 90 and 120. If you just look at kind of 180 degree sections, so we've got a line of symmetry through 90 in between 0 and 180, and a line of symmetry at 270 in between 180 and 360. So 180 take away 11.5 gives us 168.5 degrees. Next, we need to check our range. Now, the range is in between negative 180 and positive 180. Both of our answers are within that range. If we took 360 away from either of those, because these curves repeat every 360, we're going to get answers like negative 191.5, which are outside that range. So we're happy with these two answers. Next, we're going to look at the inverse sign of negative a third. That should give negative 19.5 to one decimal place. And while that isn't it on the curve we've got here in between 0 and 360, if we add 360 to it, we're going to get 340.5. So we have a look at a negative a third, which roughly is going to be somewhere right here. We can see we've got the answer right at the end, in between 315 and 360. Now, 360 take away 340.5 gives us 19.5. So we're in 19.5 from the right-hand side. Using the symmetry, the other answer will be 19.5 in from the left-hand side. Left-hand side starts at 180. 180 plus 19.5 is going to give us our other answer in between 180 and 225, and that is 199.5 degrees. Now, like the 340.5, both of those are outside of our range. We can only go up as high as 180. But we take 360 away from 199.5. That's going to give us a negative 160.5, and that is inside our range, so we can use that one instead. All we have to do now at the end, write your answers in ascending order and make sure they're really, really clear. So negative 160.5, negative 19.5, then we've got a positive 11.5 and a positive 168.5 degrees. So those are 4 answers.
Ouch! This is why in some videos I've explained scratches.